So today we're going to learn a little bit about rigging and using skeleton joints in order to animate an object. Normally, rigging is used for characters and such as human bodies or maybe animals, and it follows the logic of joints and skeleton systems. So skeletons that are kind of joints that are connected together and they're articulated so they can rotate in certain directions, right? And that's what allows movements. For example, an entire human body or specifically an arm or even a finger, right, is made of different joints that allow it to bend, and that's how we get motion. And for this tutorial, I want to work off of this shape, which is this kind of squiggly worm that I want to start to unfold at its joints. So let's imagine that each of the corners where this is bending was actually a joint, and that I was able to start to unfold this shape into a straight line. And that's sort of what I want to animate here. This is a project that I'm starting to work on, and it's a collaboration with another friend who's an artist, and she kind of makes these shapes in ceramics, but I'm going to actually make an animation with them. So let's get started. And to do this, first we want to build our starting shape. So this is basically a cylinder, right? That if we wanted this to be unfolded into a straight line, we just need to make a really straight cylindrical shape. And then we'd need to create joints for it at different points so that it bends and it turns into this geometry. So I'm going to create a cylinder, and I'm going to rotate it so that it's horizontal. And then I'm also going to rotate it in its y-axis. And now let's bring this down. It probably needs to be a smaller radius, and then I'm going to also just make it a lot longer, so something like 30 is probably good. I'm also going to add a lot of subdivisions, so I'm going to add something around 120 subdivisions because I want this to bend smoothly. Okay, so I'm going to hide this shape because I want you to see the curve that is going to kind of help me create my different segments along my cylinder. And to do this, we're going to create our joint system. So whenever we're working with skeletons and we're creating rigs, we want to make sure we're working on an orthographic view. In this case, since my shape is going to be animated along this horizontal plane, I want to be working from the top view. So I'm going to go to the top view, and I'm going to create my skeleton. It might be also helpful to go and set this to wireframe mode, and I'm going to hide my plane for now. So before we create the skeleton, let's think of the logic of how this line would need to unfold. If we started from this end, we would want to start over here on this side, right? And so this first section is much shorter, so we would first need to add a joint somewhere here. And then from this section to this section, it's about the same size, so we'd add a second joint here. And then this third section is a little bit longer, so then we'd add another joint here. So let's go ahead and get started. Make sure you're in your rigging rollout menu, and then go to skeleton, create joints, and let's open the options window. So when you're working with joints, it's always good to reset your tool, and then check your short bone radius and your long bone radius, and if they're different numbers, they should always be the same, or else this is going to affect the radius of your joint, and if one is bigger than the other, it might affect the way things bend. So it's always good to kind of get them to the same number. I'm going to make mine 0.1 since the radius of my entire cylinder was 0.4 and I want my bone radius to be much smaller. So this is about right. And then everything else right now we can leave as is, and we'll be able to look into these settings later. So let's close this and then let's start creating our joints. So again, we're starting from the right side, going to the left, and if we unfolded this shape and this was on the right, we're going to use these lengths as a reference to create our joints. So make sure you're somewhere around the center and click on your first point. And then if you hit Shift and you create your next joint, it should be in a straight line. So this will help you keep your joint system aligned. So I'm going to make my next joint somewhere around here. And then the second section is about the same size, so I'll leave it somewhere around here. And then this section seems to be twice the size, so maybe I want my joint to be a little bit longer. This section is short again, so I can make a shorter section. And then I'd make a longer section again. And then this next section is really long, so I can kind of maybe exaggerate and go all the way over here. This next section is a little bit shorter. And then we can bring things down to maybe the same distance. And then this last section, this diagonal, is a little bit smaller, so it's somewhere around here. And let's make our cylinder a little bit shorter. So I'm going to shrink it so that it's the same length as my skeleton rig, and this looks about all right. Maybe we need to scale it down a little bit more. So I'm going to scale it to 0.9. Whoops, that's too much. Okay, this looks okay. So I'm going to zoom in, and you can see that my joint is showing in the outliner. And if I press this plus sign and I start to open up my entire system, you'll see that there's this kind of parent-child relationship, right? Where there's this main joint that is the parent, and then joint 2 is a child of joint 1, but joint 2 is the parent of joint 3. So there's a certain hierarchy that makes this entire system be connected and work in this relationship. So for example, if I go over joint 4, anything I do, for example, rotate on joint 4, will affect all of its children. So joint 5, 6, 7, 8, 9, and 10 will rotate. If I go to my first joint, everything under it will be affected. So you can actually, after creating your skeleton, go in and adjust the position or size of each joint. So if for some reason you want to kind of fix certain locations, for example, make sure everything is centered, you can still go in and do it and edit it after creating your joints. So I'm going to make sure everything is centered. And again, it's good to actually start from the first joint, since everything is in that hierarchy, and then go down, or else you won't really be affecting one joint, but you'll be affecting all of the next joints. So everything looks centered here. This needs to come down a bit. so on. Okay, so things look about right. I'm going to stretch this joint so that it's right in the edge. And I have my entire system working now. If for some reason you accidentally rotated joints, you can always go to select all of them and then go to skeleton and orient your joint. This is a good exercise to do before attaching your joints to the cylinder, because it's important to have everything correctly oriented. And what I mean by this is, if you go, for example, to a perspective view, you should have each joint, this red line should be pointing to this joint's child. So joint 6 should have a red line pointing towards joint 7. So let's go ahead and check each joint and make sure they are correctly oriented. So in this case, this red line is pointing towards joint 7, and then joint 7 should be pointing towards joint 8, and so on and so forth. And everything is now correctly oriented because I selected all of my joints and I oriented them. But make sure yours are also correctly oriented before we actually attach them to the cylinder. Once everything is correctly oriented, you are going to select all of your joint components in the outliner. So make sure you have them all dropped down and select all of them. And now hit Shift and select the cylinder. And now you're going to go to Skin and Bind Skin. So now let's deselect everything, and you'll see you have kind of like a rainbow in your joints happening. And this means that everything has been correctly attached. So our skeleton system should be working now. So let's go ahead and try and rotate our first joint and see how now my skin, or my cylinder, has become the skin of my skeleton, and it's rotating correctly. So I could go now to each joint and rotate it so that I can get my squiggly shape to happen. And everything seems to be working correctly. The reason why I'm using rotate and I'm not moving things around, for example, if I wanted to move this joint, is because this is not really how joints work naturally. Our joints, for example, in our fingers, right? They only rotate. They're articulations, so they don't really move. All of the movement happens thanks to the rotation. So in order to get anything to move, it's by working with rotations. So I'm going to get my shape to be as similar to this curve that I drew. So for example, here this section could have been a little bit longer, but it's a little bit too late to move it now because I've actually already binded my joints to my skin. But if you strongly wanted to kind of correct this, you could always go to select your skin, which in this case is my cylinder, and you could go to unbind skin. And so this will detach everything, and then you could go back and edit your joints and redo this whole step. We're just going to keep going for now and keep working on this, but know that you can always kind of undo this procedure and unbind your skin and then work on your skeleton. Okay, So here we go. Again, this could have been a little bit better, but for the case of this tutorial, this is okay. So this is what my shape is looking like right now. And now if I wanted to start to animate this, I would actually have to go into each joint, right? And start to rotate it and then keyframe the way we've learned how to keyframe objects. So this type of animation is called forward kinematics, and it means that you're actually controlling the position of each joint by rotating it. And so, for example, if we wanted to get this end, this last joint, to maybe reach all the way to this space, we wouldn't really move it, right? Because this wouldn't unfold everything. It would just kind of stretch this part of my geometry, and that's not really how skeletons work. Again, they work by rotating joint systems. So if I wanted to get this to this position, I would need to start to unfold things so that that happens. So for example, I would need to maybe rotate this out, and then maybe have this joint also slightly rotate, and then maybe this next joint, this joint is fine, but maybe this next joint would have to rotate too. And so you see, this is how I would be actually designing my motion, right? I would need to kind of think of how every joint needs to rotate so that I get this point to that end part where I wanted it to be. So let's do a quick exercise and keyframe some of these joints so you can see how I can animate this. And then the next tutorial will be about inverse kinematics. So in inverse kinematics, you define the joint limitations, and then by just moving the end joint, Maya can calculate the position for all the rest of the joints. So we'll look into that in the next tutorial. But for now, let's try and animate our shape. So let's go ahead and keyframe this. And I've selected all of my joints to make their starting point this position. So I've selected all of them and I hit S to create this first keyframe. And then after this, each joint will be keyframed individually. So let's say that I'm going to move a couple of frames forward and I want my first joint to unfold to be this one. So joint 7 will start to unfold. And maybe if we go to orthographic mode, it'll be easier to control things. So let's have this unfold into maybe like this shape, and then I'm going to hit S. And I'm going to maybe also have this other joint unfolding at the same time. So I'm going to hit S, and let's go back. Okay, this is looking good. And I'm going to move forward a couple of frames, and I'm going to maybe unfold this joint to here, and then I'm going to hit S, and maybe I also want to have this joint unfold. Oh, not that one, actually this joint. So I'm going to have this joint unfold in this direction, and I'm going to hit S. And I'm going to move forward a couple of frames, and now I want to have maybe this joint here start to unfold. So I'll hit S again, and this other joint should also maybe start to unfold. So hit S. So slowly everything is starting to unfold. So from this shape, I'm kind of having this character stretch out. Now I want to unfold this joint. So hit S and move forward some frames, and then this will be kind of the big unfold. So maybe I even want to have more frames happening. So let's unfold everything here. And maybe towards this moment, I want to start straightening things. So I'll hit S again here, and maybe I want to rotate this too, and hit S, and maybe this other joint here. I'll hit S. And this can unfold too. So let's see what this looks like. So it's this kind of long shape. I'm thinking if I want to have it also moving a little bit, so maybe I'm going to keyframe this so that it's kind of moving while it stretches out. And then let's just go to the end and straighten everything out and keyframe this last part. So again, just kind of straighten everything out, and to do that you probably want to start from your first joint and rotate it, and then this will kind of guide the orientation of all of the next joints. So I'm going to keyframe this and then go to joint 2. This is already pretty straight, and then I'm going to go to joint 3 and straighten this out. And just make sure you keyframe every time you have your final position for each joint by pressing S on your keyboard. This looks fine, so I'm going to keyframe that. And then maybe rotate this last one a bit, keyframe it. And then joint 10 doesn't really matter because it's the last part. So let's play this animation. I'm going to go to shaded mode. And maybe I'm going to go to perspective mode so you get a better idea of what I'm looking for. Show my plane, and I'm just going to make this a different material. So let's play this. Okay, so this is working pretty well. Again, this is forward kinematics because I've actually decided the rotation for each joint so that I can get my shape in the right position, right? So I'm the one who's calculating all of the movements and rotations that need to happen to get to this end result. In the next tutorial, we'll learn about inverse kinematics, which works a little bit different because we define certain limitations and then Maya does the rest.